Okay.
There's not like a specific worksheet. It's just like out of the book.
Okay.
But I wanted to work on like cosine and sine and all that stuff, you know?
We can do probably most of that stuff by having you verbalize it. What kind of,
Okay.
you have some specific problems or?
I mean, I'm just like, we're just learning like cosine, SOHCAHTOA, or whatever you know now.
Okay.
And I'm just like kind of confused on some of that. So, I mean, you could just like give me some problems to
Yeah,
work on
I
to
can.
explain it. Thanks.
And this is, what class are you taking, Hannah?
Geometry.
Okay, so this is the trig that they're teaching you in geometry, which is
Yes.
generally when they introduce you to trig. So the problems aren't going to be uh, super hard, pretty introductory. If I said to you, what is the sine of theta? We take trig functions of angles to get ratios. So what does SOH mean?
That's sine, isn't it? Opposite over hypotenuse.
Okay, so what's the opposite over the hypotenuse?
Like in this triangle problem you have here.
Uh-huh,
Wouldn't it be like 3/5?
that's it. Now tell me what the cosine is of theta.
Um, so would your adjacent be the 4?
Yeah, when they say adjacent, there's always actually two sides that are adjacent to any angle. They're always referring to the side that is not the hypotenuse. So
Okay.
you're looking at sides 4 and sides 5 being the adjacent sides of theta. They refer, the adjacent that they mean is the 4 distance.
So it'd be 4/5 then.
And what is tangent
Um,
of theta?
that wouldn't that just be that'd be 3/4, right?
You got it. Now, what if I said angle alpha? What's the sine of alpha?
Is that the x?
Well,
So
alpha is
that's what I
just
don't know.
another Greek letter like theta. And
Okay.
usually Greek letters are what they use to represent angles. Okay.
Okay.
So this is just a different angle. There's two non-right angles there. So what's the sine of alpha?
So do I just use the sine, cosine, and tangent
You
still then?
use SOHCAHTOA. That's where
Oh, okay. So I
everything
see what you're
begins.
doing here.
Everything begins with trig with SOHCAHTOA.
Okay, so it would be 4/5.
And what's the cosine of alpha?
Um, 3/5.
And the tangent of alpha.
4/5. Or
Four,
no, sorry.
4/3.
4/3.
Okay. Now, have they taught you the other three trig functions? Cotangent,
Um,
secant, and cosecant?
I don't think so.
Okay. They may not this
Okay.
year. Eventually, when you take a trig course, you'll get those three. But I wouldn't be surprised if they focus strictly on these three trig functions. What kind of calculator do you use, Hannah? Is it a TI-84 or is it a Inspire?
It is hold on, I'm grabbing it real quick.
Actually, it might be.
TI-84 plus CE. That's what it
Okay.
says.
So you'll notice on the TI-84, there's a sine, cosine, and tangent key,
hmm
but there aren't the other three. There's no cotangent, there's no secant, and there's no cosecant. And these are the other three trig functions. And the reason they don't put them on your calculator is because the cotangent is the reciprocal of tangent. And the secant is the reciprocal of cosine, and the cosecant is the reciprocal of sine. So if I said, what was the cosecant of theta, I just take the sine and reciprocate that, and that's your answer. Okay? We don't need to talk about these three, but I just wanted to make you aware that there are three other trig functions that are merely the reciprocal. In other words, the cosecant of theta would be the hypotenuse over the opposite. That's how I would get 5/3.
So you're just switching the two.
That's what the reciprocal means. Always remember that we take trig functions of angles to get ratios. Ratios are always important. You would never want to put that answer as 0.6. You just wouldn't. The answer for the sine of theta is 3/5. In other words, it's the opposite side over the hypotenuse. Now, if this is a 6, 8, 10 triangle, which is just a multiple of the 3, 4, 5 triangle, well, then the sine of theta would be 6/10, and you could simplify that to 3/5, but you wouldn't want to really give it as a decimal. In other words, the ratio is an integral part of trig. When you take a trig function of an angle, you get a ratio. Now, it's, that ratio could be a whole number. It could be 3/1 or something, but you get a ratio. Now, I don't know how far to take this. I could spend 3 hours introducing you to trig. I really could. There's that much that I could just do it without any help from you. I could start on trig and go as long as I would get after 3 hours. So I'm not quite sure what else to give you. Do you have an example of any problems from the book?
So like
idea of where they're at in trying to teach you this.
Okay, so like how do you want me to like explain the problem or like
however you can read it, try reading it out of the book and I'll see if I can figure it out. And if I can't, I'll ask you to send me a picture of it.
Okay, well, this is like, I wrote this down in my book from today. It's like one of our problems.
Okay.
So it's it's a rectangle with 90-degree angles, except for the top two. So the bottom two are 90-degree angles. And then it's 8 centimeters on the...
Is this a rectangle or not?
Yeah, because it looks like a square, but
it's... angles are 90 degrees. That's the definition of a rectangle. All four angles have to be right angles.
Well, there's a triangle on top.
Okay, like that.
Mm-hmm.
Okay.
Kind of. And then like...
Meaning it doesn't go from end to end? It just...
Do you just want me to see if I can send you a picture?
This...
Here. Is there like a way I can send you a picture over text or do I do it over email?
The best way is email. In other words, my text goes to my phone and we're looking at my computer. So if you send it to my email, then I can bring it up on the screen. Here, let me give you the best email address to send it to.
Sorry, that'll probably just be easier.
Yeah, it probably is. With geometry, frequently you have to send me. There's just too many problems that deal with graphs or objects, shapes, things like that. So send me a picture to this email and only attach one picture at a time. Are you using an iPhone?
Yeah.
Send it as a large file attachment or as actual size. I think large file actually works the best, but do not send it as a small file attachment. That doesn't work very well at all.
Okay.
Tell me after it says sent. Files.
It just sent.
Okay.
So it was wanting us to find the area using like sine and...
Okay. That's not a rectangle. That is a trapezoid.
Okay.
Okay. And the difference is with, here, let me blow this up a little bit. Easier said than done. But I don't need to blow it up. Okay, so a trapezoid has two opposite parallel sides. In other words, this side is parallel to that side, but the bottom is not parallel to the top. That's the definition of a trapezoid. Okay?
Okay.
However, all quadrilaterals, what are the total of all of the angles in any quadrilateral?
180.
360 for a quadrilateral.
360.
For a triangle, it's 180. But for a quadrilateral, it's 360. For a five-sided figure, it's 540. So it goes up, okay? So if I know the total angles are 360, then that's 90, that's 90, that's 126, correct?
Mm-hmm.
Which makes this one 64. No, 54. They have to total, in other words, the top two have to total 180 because all four of them have to total 360. So that's 54 degrees. And they want the area of this whole figure?
Yeah.
Okay.
The area.
So I can do two things. I can break it up into a triangle and a rectangle, which is what I have done. Now, they're missing a measurement here.
Mm-hmm.
No, they're not. No, they're not. Sorry. This, if I look at just this triangle right here,
Mm-hmm.
let me draw that separate. Okay?
Okay.
Because sometimes it's easier to see stuff when you look at it separately. What's this angle, the acute angle that I'm pointing at right here?
36.
Okay. That's 54. And we know that's 9.
Mm-hmm.
So if I wanted to write an equation using trig,
Mm-hmm.
I could say the cosine of 36 degrees equals what? I'm going to call this side x because I don't know what it is. But that's what I'd like to solve for, because if I can solve for it, solving for the area of this object is going to be a piece of cake.
Mm-hmm.
So
So would it just...
what would it be?
9 over x?
Ka is the adjacent over the hypotenuse.
Oh, okay, so x over 9.
So ka toa is x over 9. Okay. Well, cosine of 36 degrees, you can get out of your calculator. Go ahead and give me what that number is. And you got to make sure you're in degrees, not radians.
Oh, yeah. How do I go to mode? I found it, yeah. Okay, here we go.
Type the sine of 30. If it gives you 1/2, you're in degrees. If it gives you anything else, you're in radians.
Here, I figured it out.
You got
I got
to
zero.
go to mode and you go down 3 steps to where it tells you what you're in.
I got 0.809.
Okay, so 0.809 is the cosine of 36 degrees?
Mm-hmm. Before it gave me negative 0.127, but then it gave me this when I changed it.
Let me get my calculator out. Check that, because that doesn't sound right to me. And I need my calculator that allows me to do trig. So if I hit the cosine of 36, actually I have a calculator that I don't know how to use. Let's see, if I do the sine, interesting. Hold on, let me get my other calculator. On your calculator, do the sine of 30. Tell me what it says.
0.5.
Okay, you're in degrees. Now do the cosine of 36.
0.809.
Serious?
Yeah.
Okay, let me do it on my, because for some reason that does not seem correct to me. Hold on a second. Let me check the sine of 30 to make sure I'm in the right mode. I'm not. And good grief. Okay, hold on a second. I'll get in degree mode here. Hold on. You think your calculator is tough to switch between radian and degree. Mine is terrible.
Oh no.
Mine's a better calculator, believe it or not. The Inspire is top of the line, but it's very weak on switching from radian to degrees. Now, I get square root of 5 plus 1 divided by 4. Square root of 5 is what? 2 and change, so that's 3 divided by 4. That must be the right answer. I'm shocked because here's what the cosine curve looks like. Notice that at 0, it's equal to 1. And at 90 degrees, it's equal to 0. So what you're saying is that at 36 degrees, it's still relatively high up there. And that's 0.809. Okay, I'll go for that. So if we label our picture here, sorry to spend so much time trying
you're fine.
to counter that. So that's what that side is, times 9. Multiply that number by 9. You see why I have to multiply it by 9?
Yes. Because you have the x over 9.
Over 9. So if I'm solving for x, x is actually equal to 9 times cosine of 36. So what does that mean?
I got 7.28.
So that is this distance. The bottom of the triangle is 7.28. Yeah. Okay, now it might be nice to know this distance over here, because if I can figure out y, then I have all the distances I need to figure out the area of the rectangle and the triangle, which I could figure out separately, but I got to know the height of that triangle. So give me a trig equation that lets me solve for y, if that is 36 degrees.
Okay, would it be
What we need is the trig function that's going to relate y to 9.
So sine?
Exactly. And that, in other words, it doesn't do, if I said tangent, well, actually that would work also, because I now have this measurement down here. But the easiest thing is the sine of 36 degrees is going to equal y over 9. So y is going to be, what is 9 times the sine of 36 degrees? Do sine of 36 degrees first. That should be relatively near a half.
I got.
And multiply it by 9.
Oh, wait, hold on. 5.29.
All right. So now it's a geometry problem. It's no longer a trig problem.
Okay.
Okay. So let me erase most of what I have up here. And let's solve. Now, I could do this two ways. I could solve it the area of a trapezoid, but then you'd have to remember the formula for the area of a trapezoid. So let's solve it as the area of the rectangle and then the area of the triangle, add them together. That's what they want, is the total area of that figure. It's the area of the rectangle.
7.28 times 58.24.
And what's the area of the triangle? What's the formula for the area of a triangle?
Isn't it just the base times height?
1/2 of that.
Okay, so base times height divided by 2.
Yes.
Okay, so 5.29. 19.25.
Add those together, you get 77.49. That is the area. Now there might be some round off area there. Round off error, rather. Did she tell you how many decimal points she wanted you to take it out to?
I just think 3. So
3?
Yeah, I'm not sure though.
Okay, well, if we wanted to do 3, then we really should carry that out to 4 places. And in fact, we should carry out all these numbers to 4 places. In other words, the 7.28 is only to 2 places. Same with the 5.29. So if we want our final answer to be to the thousandths place, which is 3 decimals, then we need to make these at a minimum to 3 places and probably 4, just to avoid round off error. In other words, if you make your numbers to an extra decimal place as you're doing your calculations, then when you get your final answer and you round it off to 3, there's a far greater likelihood that you'll have the correct answer rounded off. Whereas if you round everything off to 3 and then start adding, you could see that I could get a final answer that would be off in the thousandths place.
Mm-hmm.
So if this called for rounding it to 1 decimal, then we're okay, because now I can round that to that. If
Okay.
it calls for rounding it to 2 decimals, we're in danger. I could be off by 1 here easily, because I've rounded these early. In other words, I rounded the 7.28 immediately, the 5.289 immediately, and then after I multiplied them together, I rounded it again. So I could be accumulating round off error really easily. So it really depends on how many decimals she wants the answer in.
Okay.
That's how to do the problem. If she wants it to 2 decimal places, then my suggestion would be to do all the preliminary steps to 3 decimal places.
Mm-hmm.
And then when you get a final answer to 3 decimal places, round it off to 2.
Okay.
Okay. Now let's go back to this triangle. Why is the area of a triangle half the area of the same rectangle? In other words, the rectangle would be base times height, right?
Mm-hmm.
No matter what kind of triangle I put in there, it takes up half of that space.
Mm-hmm.
Even if I draw it like this, it's half that rectangle. Or if I draw it like that, it's half that rectangle. Or worst case scenario is I draw it like this. In all those cases, the triangle is half the area of the rectangle. And that's why the area of a triangle is 1/2 base times height. It's not base times height, but half of that. So if you can remember that triangles are always going to be half of the area of the rectangle, in other words, if I make that a rectangle, the area of that rectangle is twice the area of that triangle.
Okay. That makes a lot of sense.
So we got this problem right. This was the area of the rectangle, and this was the area of the triangle. We added them together. The only possible mistake we might have is some round off error. And I don't know unless the instructions told you how many places to round it off to.
Yeah, it didn't say anything, so I think we're good.
Okay.
Yeah.
All right. What else? We don't have a lot of time. So
yeah.
Hopefully that gives you a decent idea of trig. Notice what we were able to do using trig. By merely knowing this angle of this triangle and one side of it, I was able to come up with x and y, the base and the height, by merely knowing 36 degrees and 9 because of those trig functions. In other words, the cosine of 36 degrees is always the same number. It never changes. When I was younger and before calculators, you used to have to look it up in a table. Seriously, you had to. All the trig functions you looked up in a table and came up with a number. But by knowing what that number is, it allows you to solve for that variable. And by using the cosine function, you can solve for that variable. And then you've solved the triangle using trig functions. So that shows you the value of them. They're tremendously valuable, and it would work regardless of what that degree angle was. I could be 37.5 degrees, and I can still find the cosine of 37.5 degrees. Gee, I like this blackboard with colored writing on it. I gotta figure out maybe how to get a black background like that always. I like that a lot. That's more appealing than I usually have a white background that I use black on. So, all right.
Yeah.
Hannah,
Well, thank you.
have a good rest of your week, and I'll talk to you next time.
All right. Thank you.